Hello guys, so in this video I'm going to talk about how to take derivatives of trigonometric functions. Reason being is because a lot of times these derivatives are supposed to be very basic derivatives, so the idea is that you're going to use them in conjunction with a lot of other forms of derivatives like the product rule, the quotient rule, the chain rule, implicit derivatives, all etc. right? So you want to get comfortable using trig derivatives just because they come up quite frequently. So in this example, or in this set of examples, I want y'all to notice just a rule of thumb are these derivatives are just basically they should be second nature. So we don't do a lot of memorization in math, but one thing I will tell y'all is to go ahead and memorize these. Memorize the derivative of sine of x is cosine x, the derivative of cosine x is negative sine, and get used to the sign change for cosine. The derivative of tangent of x is secant squared, secant x squared. The derivative of cosecant x would be negative cosecant times cotangent. The derivative of secant x is secant x times tangent x, and the derivative of cotangent x is negative cosecant squared x. So get used to these because they come up a lot. They come up a lot in other forms of in conjunction with other derivatives. So, and we're not going to worry about what if there's a constant inside the function. All these examples that we're going to do are just going to be functions of x. If there's a constant in front of the x, then we use what's called the chain rule, and that's in another video, which I'm not going to go over in this video, but you can check out that video as well. So without further ado, so the first example, we're given 3 cosine x. So the first thing we do is we notice that it's cosine x, right? So, or the first thing we do is we're going to go ahead and just ignore the 3. So we're going to focus solely on cosine x. And what's the derivative of cosine x? We change the sign. Always for cosine, get used to changing the sign. So whenever you take the derivative, which we're going to note as y prime, the derivative of cosine x is negative sine of x. But let's not forget we had a 3. So the actual derivative of 3 cosine x, y prime, is equal to 3 times negative sine of x. And if you want to be more proper, the derivative of y prime is negative 3 times sine of x. So the idea is the reason why I remove the multiple is because the constant, I don't want you to focus on it. Whenever you're taking a derivative, solely focus on the trigonometric function and then apply the multiple at the very end. And not just in this video, but in taking derivatives or integrals, try to pull out all the constants and just multiply by them once the problem is already solved. So for the next example, here we have 4 times sine of x divided by cosine of x is equal to y. So the first thing we're going to do is we're going to remove it, and we're going to solely focus on sine of x divided by cosine of x. Now, if you know your reciprocal identities, you know that sine of x divided by cosine of x is equal to tangent of x. So, and we know the derivative of tangent, as right here is given to us because it's a rule of thumb, would be secant squared x. Now, don't be confused and put secant x squared because that's a totally different function. So don't do that. Remember, secant x, the whole function of secant x is being squared. So that's why we include the square here and not inside the parentheses. Now, we did multiply by a constant 4. So the actual derivative of y prime is going to be equal to 4 times secant squared x, and that is our derivative for sine of x divided by cosine of x. So for our next example, we are given 4 cotangent x is equal to y. So the first thing we're going to do is we're going to ignore the multiple. So we're going to just ignore it for now, just because it doesn't help us solve the problem. So we're going to solely focus on y is equal to cotangent x. And then when we do that, we look for the derivative of cotangent. And these, I would say memorize them for exams, but whenever you're doing your homework, just have these 6 derivatives with you, so that way, because they're just basically derivatives that you should know, or you should, I guess, have memorized for exams. So the derivative of cotangent x, y prime, is going to be equal to negative cosecant squared x. And like in the previous problem, don't make this mistake. Don't forget the minus sign, because it happens to people a lot. And more than anything, don't do this. Don't put the squared inside the x, because you will get it wrong. That's a completely different function. So for this function right here, negative cosecant x squared, and don't forget that we had a 4 in front of it, so y prime is actually equal to negative 4. That's an ugly 4, but you get the point. Negative 4 cosecant squared x. So that's our function. And don't forget the minus sign for cotangent, and don't forget the multiple. But I do tell you to ignore it, so that way you can solely focus on the trig function. Just don't forget to add them, to multiply them back in at the very end. So for the next problem, we're given 7 secant xy. So the first thing we do is we ignore the constant. So ignore constant. So we focus on our y is equal to secant x squared. And the derivative of secant x is, we look for it, and it's secant x times tangent x. So the y prime is equal to secant x times tangent x. And now we multiply by the constant. So y prime is actually equal to 7 times secant x times tangent x. And this is a derivative of y prime. So pull the constant out, find your derivative using these right here, and then multiply by the constant again. But just practice and get used to them. Now right here, we have a weird looking function, because we have 10 divided by sine of x is equal to y. So the first thing we're going to do, and I feel like it's helpful here, is we're going to ignore the constant. So ignore constant. Constant. So y is equal to 1 over sine of x. And if we know the reciprocal identities, we know 1 over sine of x is equal to cosecant x, because the inverse of sine is equal to cosecant if we know the reciprocal identities. So now the next step is to take the derivative of cosecant of x. So y prime is equal to the derivative of cosecant x, which we have right here actually. Negative cosecant x times cotangent x. Do not forget the negative sign, because it does happen to a lot of people. So negative cosecant x times cotangent x. So now that we have that, let's not forget, let's multiply by constant. So let's multiply by the constant we pulled out. So our y prime is actually equal to negative 10 cosecant x times, I'll make sure I'm gonna make this more legible for y'all. So y prime is equal to negative 10 times cosecant x times cotangent x. So make sure you don't forget the negative sign. But more than anything, the key to trig derivatives, because these all had x of 1, right? We didn't have 2x, 3x inside. We didn't have x squared because those are different derivatives, where we do need to know the trig derivatives to do those derivatives as well. The trick to trig derivatives is just knowing these 6 right here. So know the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent x is secant x squared. And know that their opposites are equal to each other. So the derivative of secant x is secant x times tan x. The derivative of cosecant x, think it's cosecant x times cotangent x, but with the negative sign since it's a negative. And the derivative of cotangent x is almost secant x. It's cosecant x. It's its opposite squared. It has the same form except it's a negative and it's opposite trig function. Make sense? So basically, just get used to them. Do a bunch of them, practice them, because it'll eventually become second nature. But thank you for watching, and I really hope that was helpful.